Fact for this episode: in the fight against the rising cost of energy and building and equipment maintenance, there really is a way that you can see into the future. So let's get into how. Welcome back to the Corporate Sustainability Education channel. We're powered by the Southern Sustainability Partnership. In this episode, we wanted to put the spotlight on thermal imaging technology. It's a unique opportunity to press the fast forward button to enable you to plan to address problems well before they become a costly catastrophe. We're therefore delighted to go behind the camera with one of the UK's leading experts on this technology, Richard Wallace, who is Managing Director of UK and Dubai-based company TI Thermal Imaging. Welcome, Richard.
Hi, Linda. How are you?
Yeah, very well, thank you. Really pleased you can be here.
Good.
You're a
Thanks very much.
busy man. We're lucky to get you. So for the first time, this technology enables organisations to see inside the fabric of their building or their equipment. In layman's terms, can you explain how a thermal imaging camera operates?
Yeah, so that's actually a misconception. It doesn't actually allow you to see inside. What it does is take nearest surface temperature. So we can apply thermal imaging techniques to all sorts of different areas. Our main areas actually that we look at, our risk management, would be electrical thermography. So that in that sense, we'd be looking at components which are overheating but which haven't quite failed yet. So that would be in the scope of trying to keep the equipment running, so before it fails, so there's no unplanned downtime or there's no power outages. Also, on the risk management side of things, insurance companies love this because it kind of reduces the fire risk for the properties that they insure. When it comes to the energy side of things, we do an awful lot of work in the Briem sector. So Briem requires a level 2 thermographer with a what is it, a 320 by 240 minimum resolution camera. We actually surpassed that, so we've got level 3 status. And oddly enough, I managed to renew my qualification yesterday, actually. So that's quite timely. So that's a level 3 status, but we've got the 640 by 480 cameras, or in actual fact, we're currently using the 464 by 384. So it's kind of a new resolution which was released by FLIR a few years ago. So we surpassed those requirements. Now on Briem and energy losses, new builds who are going for a Briem rating, they can apply for the thermographic inspection, which I think it contributes to 1 point for their Briem rating. So we would go down to their new build very early in the morning, just before sunrise. We inspect their building, and we tell them where their energy losses are, and we submit their report. And then the Briem assessor would then go through their report and decide whether or not to apply their 1 point for the Briem rating. Another area that we operate in is water ingress on the commercial side, so we can track and try and trace where the water leaks come from. So that's quite a good one. And historically, we were very, very active in the oil and gas industry, but that's since taken a bit of a downturn. So so that's kind of where we are.
Okay, you touched on Briem, and in my limited experience, I always think of Briem as being in a new build. So it's something that's relevant to that. So are you saying that building maintenance managers have to look at Briem for the building, for the life of the building?
They don't have to look at it. It's whether or not they want to go for the Briem certification. So if they go for that certification, then thermography it's a very small part of it, but it does contribute 1 point towards their certification. And the Briem assessor would decide whether or not to issue that point.
So what would be the benefits then of going for that? If these people go into this extra level, there must be a good reason why they're doing that.
So with the I mean, it's all about the energy loss side of things. So if they get a Briem rating, then they get certified as Briem Excellence, and they can apply that to their building. So not only do they get the energy losses, they get the certification for that building that it is Briem rated.
You operate in two ways, Richard, I believe. So you use the camera as a handheld device, and also for hard to reach areas or hard to target areas, you use a drone.
Yeah, we do actually. Yeah, we don't use drones internally. We've got a very good partner that we've that actually do the drone work, and what they do is so for example, let's take an application. If there's a large flat roof that needs doing, what we can do is, or a very high building, what we can do is send the drone up. Our guys will capture the data. They send it back to us. They give us an Excel CSV file, and then we import that into our web core system. We then run through all that data, and if we can see any thermal anomalies on there, we would then take that image out, run it through the analysis, and then create a full page within that. So it's a really, really good way of getting up on top of the buildings, or the high-rise buildings, to see these areas where a walk-on just probably wouldn't be suitable. Even if you've got angled roofs that you can't walk onto, then we can do that as well. But on the drone side of things, there's all sorts of applications, not just in the building side. One of our biggest projects we did was with a major water company, and we were looking at trunk main leakages. So, and it worked really, really well because we worked closely with the teams there, with the leakage teams, and they were very, very sensible about how they applied this technology, because they would give us a series of coordinates where there was a known leak but they couldn't find it. So we then flew those coordinates and we'd find those leakage points, or potentially find them. We had some really good success, and it went right to the top of that company. So it was good. That's for the drone side.
Yes, and I think with the drone as well, then, that's going to reduce the cost of maintenance as well, because I expect companies in some aspects have always ended up hiring cherry pickers and things like that to be able to access certain areas. So it makes quite a bit of difference really to their costs. Um, Obviously, there's, the good old fashioned saying, you can't deal with what you can't see coming around the corner. How important do you feel that your customers, they have this information that you provide sooner rather than later? How important is that to them?
It depends on the customer you're talking about. That they have degrees of importance. That some customers undertake thermal imaging on the risk management side, for example. If we take the electrical side, they'll take that because it's regulation. So they've got a responsibility to ensure that their landlord or even tenant distribution gear is in a reasonable condition. So that's almost like an obligation which they have to do, and thermal imaging can be used to do that. However, we've got other clients who use it in a far more sort of proactive way, where they're actively trying to keep their equipment running. So, for example, in food production areas, it's critical that these lines keep running. So we can go and do an annual, biannual, sometimes it's quarterly inspection on the electrical distribution equipment, and we find the problems, and some of the problems we find can be catastrophic to the production line itself if it goes down. So without naming names, we've got some major warehouses on the go as well. Their conveyor systems, which we do. So in that respect, it all depends on the client you're talking to. So if it's, for example, office buildings, then it's generally, say, a once a year check to make sure that they're in compliance. Then they have their 5-yearly inspection, which is something else, a fixed wiring inspection. That's something different. But they like thermal imaging because it's completely non-intrusive, so we don't turn anything off. So they give us a call. Can you do this? Sure, no problem. We do it, and they hardly know we're there. So, and we issue their report and quite often find things. And one of the things we do as well is just little basic maintenance on panels, like if things are missing, then we'll panel fixings, then we'll just fix them up for them while we're there. We just put those in. So it's kind of like a bit of maintenance, general housekeeping on their equipment once a year.
To be able to see a problem long before it becomes a catastrophe must be the absolute ideal for any maintenance manager and for any financial director who's looking at the cost of running their business. So, have you ever had a company come back to you and say, we made a saving on that one thing that you picked up?
Oh yeah, yeah,
Can
for
you give us
sure.
any idea of, just one idea of some savings
Well,
that you've made?
if I go back to this drone inspections that we're doing, we ran them over a period of a couple of years. One in particular we found it saved the company over 100,000 just on that one leak, and that went right to the top, and that's where the directors were involved, and they looked at it and they yeah, it's because the application of the technology was correct in that we were working closely with the teams itself, so it was put into the right place, and consequently, yeah, the savings that this company made were pretty significant. And that's just one example. If you get into the electrical side of things, I can't name client names, but food production, for example, we're always finding things like this. Loose connections or components which are about to fail. I mean, Frank, one of our guys yesterday, sent me an image yesterday. He was on site and he found something 140 degrees. I mean, that is a failed connection. Even though it's still working, it is failed. So that means that eventually that will shut down, hopefully safely, but in some cases they don't shut down safely.
And then, of course, you have to find out why it shut down. So there's that process as well.
Well, exactly. Yeah, that's part of the remedials.
So, can we get into a little bit more of the nitty-gritty of exactly what you're looking for if you're called in to survey a building?
Sure. Well, on the Briem side, it's we're looking for energy losses. Briem's looking for, or the client, even if it's not Briem, even if they're just looking for an energy loss survey. Quite often, if it's not Briem and it is a client, they've got a problem. Okay, and their problem is that they're spending a lot of money on heating. Actually, domestically, we get an awful lot of inquiries this year. So just regular people like yourself and me, their heating bills are a lot. They might suffer drafts. They want to know where their money's going. So and we hear it all the time. Once we're in there, say, oh yeah, we're heating the neighbourhood. It's not quite that drastic, but yeah, essentially they're all their expensively heated air is leaking out their building, or it's seeping through the insulation, which isn't performing properly. So, I mean, there's a few things. You've got the air leakage side around the windows. You've got thermal bridging around the windows. You've got insulation issues such as you might have displaced insulation in areas. There's an awful lot of cavity fill insulation, which happened post build. And in a lot of instances, that hasn't gone in properly. I think it's critical. I'm not an expert on the way that cavity wall beaded insulation goes in there, but what I do know is that it needs to go in at the right flow rate. If it goes in too fast, then it can compact and not spread out into the cavities. So what happens is you get areas which are nicely filled, you kind of like get a donut effect, and then you get holes. So you've got insulation continuity issues on that envelope, on that building envelope.
Yeah, we've got that in our house actually, and every time we try and do something, we find it forever afterwards.
Right.
So your company's trained at the highest possible level, Richard. So just give us a little idea behind the camera, what is it exactly that you see?
So, what, from the camera itself?
Yes.
Okay, so well, it's the process really. So if let's keep it simple. So for anyone listening, let's try and tie it. If we're going to do a building inspection on their property, okay. Now the first thing we do, we want to understand how it's built. Okay, roughly what it's built, what it's built from, the materials used, that sort of thing. If it's a hoof house or an ordinary brick built house, they're two very different things. But we want to see where the energy is being lost out of that. So we would set the job up in our system. We assign it to either to one of our engineers or myself, whoever's doing the job. We would arrive on site around about 7 o'clock in the morning. At the moment, that does change. So as the mornings get lighter, then that becomes earlier. And the reason we get down there at that time is so that we don't get any solar gain. Okay, So to come back to your question, what do we see behind the camera? So when we get to that property, it's usually dark, but the infrared camera is not light sensitive. It's got nothing to do with visible light. So the image will be the same if it's light or if it's dark, okay? And what we'll be seeing from an external perspective would be elevated temperatures or lighter colours from the building envelope where the energy is coming out of the building. Okay, so the colours would be lighter, and that's what we would be seeing. Now, the trick here, this is really important, is to know what levels are important or not. Okay, so we arrive at a threshold temperature. So we base that on the internal temperature of the property and the external surface temperatures, and that gives us a temperature that we can work to. Now, if we're looking at the external of a property, we're obviously looking for elevated temperatures. So anything above that threshold, we can then mark with what's called an isotherm. And an isotherm is a very obvious colour on a thermal image. So in building inspections, I like to use an iron bow colour palette. And the reason I like to do that is it's quite cosmetic, really, because I'm working with temperatures and I know where the levels are going to be. So when the user gets the report, it's quite a pleasing report to look at. If we were doing electrical surveys, then it's kind of a bit more industrial. So we use a high contrast palette, and that gives us gradients on temperatures for faulty components. So we can actually focus right down where that is. And that's important because if we've got some kind of loose connection, we need to understand if it is actually a connection issue or a crimp issue. So you see where you've got the crimp on the wire, and then there's a nut that holds that onto whatever it's connecting to. Using a high contrast palette, we can figure out what it is. Okay, so that's kind of what we see behind the camera.
If an organisation suspects they have a problem, and they can't detect obviously where it's coming from, how should they explain this issue to you? And how should they prepare for you to come on site?
So it depends what the problem is. If an organisation has a problem specifically, let's say they've got a water ingress issue, that's a visual thing. So one of their employees may be complaining that they can see water dripping down and there's staining on the ceiling, that sort of thing. So that's quite obvious. So that's their problem. So then they come on to us and they say, right, this is what the problem is. We want to do a track and trace, try and find out where this is. We'll go and run an investigation on and all around that area and beyond to try and track where that issue is coming from. So water is really difficult to work with because it will follow the path of least resistance wherever. So what could be starting in one corner of the building could be tracking across a slab and coming down the other side. So that's always difficult. On the electrical side, it's a bit unusual. Unless there's an event, say a transformer blows up or something, then it's unusual for them to say we've got a specific electrical problem. With the electrical side, that's planned maintenance. So that means they've already got a strategy in place to use and apply thermal imaging on their equipment. Okay, so it's not necessarily a problem. Although we do get called out for things like, oh, something's happened, something's blown up. We want to check that it's okay, after the repair. So it all depends what we're applying it to, be it electrical building or whatever it might be, or water leaks for drones, the trunk lines.
If, on the other hand, you're conducting a full site survey, how should a company prepare for you to come on site, and what access do you generally require?
Okay, so if we stick with the building side of things, the energy side of things, there's a few criteria we'd like to have for a successful survey. Firstly, and this is on our part, we have to turn up before sunrise. Okay, and that's obviously, as I said before, that's to reduce the effect of any solar gain that might happen. Brickwork can hang on to its temperature for hours, 8-9 hours. So if this is a non-steady state environment we're working with. So we have to give, whatever building survey we do, we have to give it its best chance of success. Okay, and I think Code of Conduct a few years ago, they were talking about being done after dark. Well, you've got to take it further than that. So you've got to allow the building to equilibrate overnight, both to allow the solar gain to reduce as much as possible, and the most optimum time there is just before sunrise, because that's giving the building is whole, the longest time for any solar gain to leave the elevations of the property. Okay. The other thing is we need to have a temperature differential between the internal and external. Code of conduct, I think it's the BRE 176, suggests that it's a 10-degree differential. That's the accepted code of conduct, and the differential is the 10-degree between the internal and external. It can be either way. So if you think in Abu Dhabi, they don't get 0 degrees over there. So in Abu Dhabi, if we're doing building and villa inspections over there, we're actually using the AC to our advantage. Okay, so we're getting a temperature different. You know, the temperature differential is lower inside than it is outside, so it's reversed. Over here, the temperature is always higher inside than it is outside, and we do need 12 hours for that to equilibrate. Quite often, I had one yesterday actually. He turned up on site, and the guy said, "Oh, I'll turn on the heating because it wasn't on in one particular part." And as much as we'd like to say, yeah, that's fine. Unfortunately, the building hasn't equilibrated for that temperature, so it's no good. Also, we like to have all the doors and windows shut where possible, and the internal doors opened to try and get a uniform temperature throughout the building.
Is it better for you to have an operative going around with you? And if that's the case, how do you get anyone to volunteer to get up that early in the morning?
When you say an operative,
Somebody that knows the site very well, perhaps their maintenance manager or
yeah. Okay, so on the building side of things, it's usually you've got the site manager, or sometimes it's just a security guard just to let us in. That's all it is. So we just need to get access into the internal of the property. We take some spot readings around the temperatures, so we know roughly what the temperatures are on the elevation that we're looking at inside. So, I mean, one side, it could be 22 degrees one side on one elevation, and on the other side, it could be 17. It could be 0 degrees outside. You've still got your 17-degree differential that side and your 22-degree differential this side. But what that means is that your threshold is changing for the elevation. So it's important to understand what the internal temperatures are where you're assessing the elevations of the property from an external perspective on the commercials. You see. So to go back to your question, yeah, quite often as a security guard or a site manager, the difficulty arises. There is a misconception actually you can't do this in the summer. That's not strictly true. I keep quite a tight eye on this, but quite often in the June, July, August months, we can still get a 12-degree ambient temperature externally at say 3:30, 4 o'clock in the morning. Now that's probably where it gets a bit more difficult for them to get on site, but they do it. They do it. Yeah.
so if you have someone walking around with you, how likely are you to flag up something you've seen right there and then, or do you like to keep that for the site report?
I like to do that for the site report, and the reason being is because you can make a quick judgment on something without actually having the full information behind it. Now, again, yesterday I was on site yesterday, and we found this area on this elevation in the car park that was elevated, and straight away thinking, oh wow, there's an insulation continuity issue there. Brilliant. Right, okay. Now, if the guy was standing with me, I would have reported that there and then. Actually, I did some further investigation and found a hot HVAC pipe was connected to that wall, which increased the temperature. In which case, it was advisory only because there's something else which is happening there. So I like to leave. We know what we run our system, our reporting system is that actually means that we're writing the report as we go, but we never deliver it straight away. What we like to do is make sure we've got the full investigation, everything is done and recorded, and if there are any issues, then we try and find out why they're there. And if you're kind of doing it on the fly, then you might give false information. So it's always best to just give that information at the end, once you're sure that you've fully investigated all of the issues and why they might be there.
Richard, have you ever highlighted anything that you see as a future health or safety issue for the company?
For our company in
If you know, if you're looking obviously at what's wrong with buildings, equipment, everything. Have you ever highlighted something that if you hadn't have been able to see it that far in advance, could very well have been a safety issue for the staff who work there, or a health issue that could
Well,
come from.
absolutely. I mean, these elevated temperatures. Say if you're in an office building, and you've got a distribution board there with a hot connection, and you've got the fire risk, you've got the risk of the item catching fire. It could be in an electrical cupboard. They could have all sorts. There's other things actually, like visual. Yeah, on the health and safety side, like you get visual issues that we flag up as well. So if you think think back to the buildings you've worked in, Linda, right? I don't know if you'd remember, but this is all behind the scenes stuff. Your computers and your lights and everything just work, right? But going on behind that is they're all run from a distribution system, and that distribution system will be in a cupboard somewhere. And quite often you get tenants storing items in front of these distribution boards, which means you can't get to them quickly. So it becomes a fire risk. It's an accessibility risk. It's a health and safety issue. So not only is there a temperature-related fire risk, but there's also the fact you can't get to it because it's stored with all sorts of tenant-related products, or toilet rolls, for example, which are highly flammable. So yeah, absolutely. Yeah, we're always not just flagging thermal issues, but visual issues as well.
I'm building a picture here really of why this is necessary really to be carried out quite frequently. In other words, companies are used to having maybe a maintenance contract, on their equipment and that sort of thing. But really, this sounds to me like something that should be carried out annually, a complete site survey.
Definitely, yeah, definitely. So we on the electrical side of things, we depending on the site, we recommend an annual inspection. And the way our system works, there's two things here. We run the trending data, which automatically it compares the previous data with the current data. So let's say we've had 8 inspections done, then all of that data will be held within a table on our report, and there's a graph drawn, so you can start to predict how things could potentially fail. So if something's rising in temperature 5 degrees, per year, or 10 degrees per year, you may not want to fix it immediately, but that may give you a few months breathing space to then go and fix it. So that trending data is really important. That's great for where the load is constant. Where load fluctuates is a bit different because the trending is not going to work. But quite often you've got constant load on things. Yeah. And then you run that visual inspection as well. As you're walking around, you can find these areas that they're perhaps not up to the 18th edition, electrical safety standards. So, and it's because it's a live environment, it changes. People are in there. Then obviously it's not going to stay the same year on year. So we make sure we report on the thermal side, but also on the visual side as well.
To be able to plan in maintenance and therefore, importantly, the cost of that maintenance program throughout the year is just so important to organisations rather than waiting for the worst to happen. So can we now get into what a survey report will look like and how it's broken down? And is it something that you just supply and hand to the customer, or is it something that you need to go through with them?
So the report, to get to the first point, what does it look like? Okay. Our reports are broken down into a number of sections. So we've obviously got the first cover page, which just details where the inspection is happening. Underneath that, we have the credentials of the report and the person doing it, who's actually carrying out the inspection. Then we've got we like to put our executive summary right at the front of the report. The reason being is because sometimes you can have a 250-page report. If you put a 250-page report in front of anyone, they're just going to be blown away with it. So what you do is you put the executive summary right at the top, or this is what we do. We put it right at the top in bold, and we say, we highlight what their problems are and what they can do about it. So they can see immediately, okay, we've got some loose connections, for example, and we've got a couple of visual issues that we need to sort out. Oh, okay, great. So then as you go into that, we've got the summary page. It then lists down in a list format, it gives you the problems. And then from there, we then get into the actual problem page themselves. And that gives you the thermal image, the visual image. It gives you all the data in relation to the thermals. It gives you what the problems are, why it's been flagged, what the problems are, and what you could potentially do about it. And then following on from that, we've got our trending data, which is basically a record of the inspection. So we provide complete thermographic record of every single item that we looked at, be it this isn't just electrical now, this is buildings, water leaks, anything. So we could look right the way around a property, for example, and we record everything we look at, or most areas where we look at. We can't record every single square inch, but for example, we'd say, right, the southwest corner of room C1, for example, that's that one there. There might not be any problems there, but you've still got your thermographic record. And crucially as well, when we're doing the building inspections, that thermographic record, it shows unencumbered thermal images because it doesn't have the isotherm on there. Now, an isotherm, whilst it's really useful showing you where the energy losses are on a building report, it can also mask what the actual problem looks like. So if you've got some air leakage, quite often you get fingers of air leakage coming through the window frames or wherever the penetration is. An isotherm can quite easily go over the top of that and mask it. So we supply the unencumbered thermal images without the isotherm, so you can actually see it. So you can zoom in and see that as well. And then the last section of the report we've got is just a work order section. So they can rip that out, give it to the engineer. The engineer can go, their engineer or whoever is doing the remedials, they can then mark on that. And then it's just a quick page for field work, really, you know. And then on planning in the costs. So yeah, this comes down to your strategy and your program. If they, you know, we could do a 3-year price for you know, for a factory or an office block, and that's it. It's just set. It's once a year. We go in, we do it. Particularly in the factory, if we find faults, then that cost is nothing compared to what the potential downtime is. The highest cost to an industry that I know of and that I've worked in was the oil and gas sector. I mean, this is going back a number of years now, but one of the platforms we were working on, crikey, they were doing 100,000 barrels per day. And there was other ones which were doing 130,000 barrels per day. At $60 a barrel, you can start to see you know, if that goes down for an hour. Yeah.
Going back to what I said about having this survey done annually, I can see how important and actually how interesting it would be if you were able to look at last year's report and then they get this year's report from you, and actually to be able to look at the two and maybe see how far they've come in rectifying a lot of these issues, or seeing if, you know, they're staying on top of things.
Yeah, well, it doesn't actually stop there, because what you're talking about there is a static report. A long time ago, this is we knew that this would be about software. Our service would be heavily reliant on software, and the reason being is because of the industry standard is to hand over a PDF report, a paper PDF report. Well, what happens with that is that report then goes and sits on somebody's shelf and it's never opened. Okay. Now with our system it's different. So we run our web core system. When we issue a report, all the data is broken down. Okay, so you've obviously got the report. So if the director says, okay, we know this activity needs to be done. Have you done it? Yes, there's the report. That's uploaded onto our drives. Great. Okay. Now for the engineers who are interested in this, they've got a dashboard, and from the dashboard they can operate everything. So they can see their inventory. If they click on inventory, they can click on a piece of equipment, they can see a visual photograph of that piece of equipment and all of the activity that's happened on that piece of equipment. You can't see the thermal at that point. It's just, say, for example, DB1, then they can go in and see, oh, right, we've had inspections on these dates. Oh, in the third inspection, we had a fault there, which is now closed or it's recurring, okay? We've then got a problems tab. So if you choose this is particularly useful if you've got multiple sites. So if you've got a client with A, B, C, D, E sites, then you can click on the problems tab and you can filter out between sites where the problems are. Click on that problem and it brings up the full page, okay? Then got the trending data, and this is great because you can click on a piece of equipment and you can see how it's trending over time, okay? And with the trending data, it always sorts the biggest movers to the top. So when you look at, say if you've got, I'm an engineer of site B, and my colleague is an engineer of site C, I'm not interested in his site, I'm interested in site B. So I go onto my site, ABC Engineering, site B, click it, trending data, search. I have to check the electrical box, because then it sorts the data, and then I can see, oh, I've got 250 pieces of equipment. Oh, and these top three, okay, they've moved by 45 degrees. Why is that? They may not have flagged as a fault at that time. It may not be a problem at this stage, and our engineer hasn't flagged it as a fault, but you can still look at that trend data and see there's something happening on that. We need to keep an eye on it. And it will collate that data from the 1st to the 8th, 9th, 10th inspection. The report will only show the last 4 images, but all of the trending data will be on there in tabular format.
So when you've given them the report, do you ever offer recommendations in terms of saying, these are the issues that we think are more important, you should address them first, or do you just leave that to the company to decide?
No, that's done by severity rating. So we have severity ratings for both the building and the electrical and the other inspections that we do, actually. But these are formula based. So if we were to let's take the building, for example, we can base it on temperature. So we have our threshold temperature. However much above that threshold temperature, we can grade it. So I believe 0 to 2 is a minor problem, 2 to 4 is important, 4 to 8 is serious, and then 8 plus is critical. Okay, so that's the temperature above our threshold temperature for that elevation at that time. So it's real time, you see, and then we grade it. So you say, right, you've got a critical air leakage problem here. You've got a gaping hole above your window that needs doing. It's not a vent. It's not it's not a grill. It's not a plant room. So that's how we grade those. On the electrical side of things, it's the similar sort of thing, but we use another formula. It's a different formula. And this is pretty good, actually. We put some science behind this. So we relate the measured temperature and the ambient temperature, the component rating. So, for example, it could be 100 amp fuse, and then the actual current that it's pulling. So it could be drawing 56 amps. And because we know those 4 values, we can then suggest, right, well, that should be at, I don't know, say 49 degrees. Okay, but it's not. It's at 75. Okay, so in actual fact, we've got a 30 odd degrees differential there. So therefore, we're able to severity rate it. So that one would turn out as a critical problem. And this is a good point to talk about, because one fault that I remember, I always remember this is going back a few years now, but we were at a data center, and we were looking at some bus bars in a big LV panel, 2000 amp bus bars, which is huge. And we found a temperature of 24 degrees in a 21 degree ambient, basically with a 0.1% load on it. Okay, so basically that shouldn't, well, you wouldn't normally think of that as a problem, but because we knew the load factor, then why is there a 3 degree rise on that? There shouldn't be anything on it. Turns out that on install, they hadn't done the bolts up on the back of this 2000 amp bus bar. They were loose, finger tight. So that was a major catastrophe. If they ramped that up, that would have literally exploded the bus bars. It could have been extremely dangerous.
I think it's important actually to ask you this question. If somebody is listening to this and they're thinking, this is exactly what I need to bring to my company, but obviously it's not their decision to sign off the expenditure of a survey, what would be a golden nugget that you could give them to take away so that they can go to who holds the purse strings and say, right, this is what we need to do?
It is a cost benefit analysis that you can do. So if you understand, if you're talking about production facility, for example, if you're taking strategy seriously, if you're taking the condition monitoring strategy seriously, then it's probably going to be involved, included in your annual checks anyway, or monthly checks, or whatever. But if it isn't, then it's a cost benefit analysis exercise. What does it cost me if my line goes down? What's the cost of having these guys in to do that? Just for that line, for example, you can even just break it down. Okay, we can do the whole site. It's just this line. This is their cost to do the whole survey. this is you can even say, right, it's actually only going to cost this amount for this line, but if this line goes down, then it costs this for the business. So you take that to a financial director, and he may not even be aware that this predictive technology is available. Give him that information, and suddenly they will certainly look at it.
That's why we felt it was so important to bring this technology to the channel, because I think it is an area where, some organizations are not aware of exactly what they have available to them. So you've finished doing your survey and you're going to prepare the report. In an ideal world, how long does it take for you to do that? How long can a company expect to wait before they receive that from you?
Same day. Now, on the electrical side of things, we're writing the report as we go. So we will, once we've finished up the inspection on the electrical side, we will take all the images that we've taken, we'll put them into we run a field application called Tycore, which syncs to our online application called WebCore. WebCore is what we deliver to the client. That's where all of the reports and data get synced from our field tablet Tycore. That's where we're writing the report as we're doing the inspection. We sync that into WebCore, and we then deliver that via, there's an email link that we send out. So once it's done, we approve the report off. Once we're happy that everything's done correctly, all the details are filled in, all the faults are reported correctly, we then approve that report off, and it automatically emails a nice email suggesting how to get onto the WebCore with a link, and then they can get onto it and they can immediately see the report. With the building side, it'll be the same day again, but we'll take that away and just make sure that everything we are reporting on is proper and correct, and the faults are actually faults and not as a result of something else. But again, that will be the same day. We don't like to issue building reports to domestic people immediately for the reasons I covered about 20 minutes ago. We just like to make sure that what we're reporting is actually correct, and then we'll send that into them. But it's a simple procedure. They can either, what happens is when we set the job up, they will get emailed an email and password, which they can then save. What a lot of our customers do who know us, when they know that we're doing a job, they'll just log into WebCore at say 3 o'clock, and they'll know that their report is there. But they would have also had it emailed to them as well when we've approved it off. So we've got there's a little feature on our WebCore that we see that says, is the report approved? You see the green ticked or crossed. If it's crossed, then that report needs approving and we need to sign it off. So we then send it off, and it's a way of quality assurance as well, or quality control, QC.
To sum up what I've heard, the biggest thing I think you offer a company is peace of mind for the management of their infrastructure, but also peace of mind for the management of their budgets. Would you agree?
Definitely. But there's we like to be incredibly easy to deal with. So a lot of people get into this. You know what it's like if something's particularly new, that you go to a building site and even at 18 years on, I get it all the time. I've never had one of these before. It's like, relax, I've got this. We'll get you through. It's not a problem, And we don't like to create barriers and make it difficult for people to understand the technology. That's why the reports are written in such a way. They're all broken down into sections, so they're easy for people to understand. The executive summary is right up the top, so people can see it. It's a daunting prospect that you get a brand new technology, which is it's not brand new technology. Brand new technology to them. This stuff's been around since before the 70s. All just happening is just getting smaller and smaller, and the batteries are getting smaller and longer lasting, and and more expensive. I might add, but it should be the other way around, shouldn't it? The better they get, the cheaper it becomes. I'll have a chat with Fleur about that. It's so we like to make it easy for them. And the feedback we've had on our WebCore system, we've been running that since 2013 now. It's been great. It's been absolutely great. People love it. So we aim to deliver this technology, which can be quite complicated. I don't want to be negative here, but if you deliver a report to somebody who doesn't understand it, it's very easy to make them nervous, particularly on the building side. So I think it's really, really important that you explain how it's been done. Talk to them about the colours and what they represent, and don't get too carried away with lighter colors for higher temperature and darker colors for lower temperature. It's important to understand that there are numbers behind it, which I think are important to convey, and we hopefully do that when we push our reports out to people.
Asking someone that's been in the business for 18 years, this is probably a hard one because you've seen it all. But has there ever been something in your career on site with a company that you saw that you were not expecting?
We see, yeah, it's funny actually. We've been right around the world with this. I mean, I didn't expect to go right around the world this when I first started this back in 2002. We're expecting like sort of domestic jobs in the UK. What's a domestic? I say UK. And we've been right around the world with this. The furthest places I've been in Sakhalin Island, for example, working with an oil and gas company out there. When you say something unexpected, you're probably talking about their site specific. But I saw a submarine on an oil and gas rig just to lighten the mood a little bit, and that was a freaky thing because you're standing there in the middle of this ice encased, and then there's this little periscope. You're wondering what it is. That was extremely unsettling, that was, because that could have been a Chinese sub spying on the Russians. I don't know, but yeah, one particular electrical fault that sticks out in my mind, and I couldn't believe this wasn't on fire. We were in a pump station. It was a fire pump station. And there was a small component there which was running in excess of 400 degrees, and I couldn't believe it. I was looking at this, we quickly got the engineer, said this needs to be shut down immediately because it's about to go. So actually, you just reminded me, there was one, James, he's our other level 3 engineer. He's been with us 10 years now. He was on a solar plant, and he found an electrical cabinet actually on fire in a dry grass field, which he quickly arrested the fire safely, and he put that out. So that wasn't actually it was thermographics, because we were there doing the thermographics, and we found it. Well, James found it. So yeah, that was incredible, that one. Yeah,
I think they call that right place, right time, don't they? Richard, a very warm thank you to your valuable insights. Thank you to Richard from TI Thermal Imaging. We have asked Richard to come back to talk about other things. I think maybe we could go into the equipment side of things a bit more. Again, Richard, if you wouldn't mind. We're also going to run interactive sessions where people can actually come on to a Zoom meeting and ask different questions. And I think if we can appeal to you at some stage when we can get a small window in your very busy calendar, it would be great if we could look at that with you as well, Richard. We've also provided a link to Richard's company website to the right of this video so that you can find out for yourself all the services they offer, everything that they can help you with, and you can see some of those lovely colours in action as well, and get a little bit of an idea of what Richard sees from behind that camera. So for now, thank you for watching, or thank you for listening, and we'll see you in the next one.